What follows is no small set of concepts. The first is genetic cascades, or as we like to call them, developmental cascades, because the genes are operating in a timed sequence. The impact on a developing organism of one gene or genes is then the foundation, the starting point for what occurs to it based on another set of genes that become operational. Therefore, any given feature is the result of a pretty long sequence of genetic events, each one operating upon what the ones prior to it has done. Furthermore, the difference between early stage changes in a cascade, which can have a profound effect on the developing embryo, and late stage effects in the cascade, which are, at least in terms of scale and physical degree, cosmetic. Add to that our understanding that genes include multiple alleles across a population, that any one of those genes in a cascade is not just that one fixed effect, but a variety of effects across the population. And the consistency of outcome in a species is typically thought to be due to redundancy. That down through the cascade, that multiple genes are operating at any given time, and that if one of them at a given step in the cascade is, for lack of a better word, weird, that its effects are frequently washed out by the conserving effects of the other genes operating at that time, and also to the strength, if you will, of what has gone before. Therefore, one would say, if we look at the individual developmental cascades across all the members of the same species, that we are actually seeing an enormous amount of potential genetic diversity that we don't see manifested in the outcomes across the individuals. One fascinating point about all this is that taken linearly, step to step to step, any of these alleles is necessarily compatible with alleles that come before and after it in the cascade. So we're not talking about weird mutations that are just popping in out of nowhere and might or might not kill the creature dead in its tracks. We're not talking about mutations that are unintegrated with the existing genetic composition. We're talking not even about new mutations at all. We're talking about existing alleles which, through the course of time, have shown themselves to be utterly compatible. Now we add the impact of population subdivision. Looking at a creature whose developmental composition is, as I've described, across all the individuals in the species, we're going to grab a few of these creatures and trot them across to an island, simply to take the easiest case of geographic separation I can imagine. What happens? We know from all the theoretical models and all the analysis and all of the observations that we've done that two things definitely apply. One of them is the founder effect itself. This scooping up of a number of individuals from the core population cannot possibly be expected to be a full demographic and frequency-based representation of the allele composition of the whole home population. Second, that given a few generations of inbreeding, and here I mean technical inbreeding with a mathematical impact, it doesn't actually have to be directly incest-based inbreeding. Given a few generations of that, the frequency of individuals with homozygous alleles, and so that for a given gene they have two of the same allele, shoots up, and that this occurs across the genetics of the organism. What I'm talking about now, therefore, is an increased chance for the cascades to bend. Here we have up and down, irrespective of position on the chain, the chance for the buffering effect of all the various alleles available for a given gene in the cascade, down the cascade, to be diminished. And since we're talking about alleles that are indeed compatible with the effective genes that came before and the effective genes that came after, we don't have to be talking about any sort of situation where suddenly an individual appears who's this weird, bonkers, possibly dysfunctional thing. We no longer have to go back to Goldschmidt's hopeful monster. Instead, we have variations that we would definitely not statistically expect to see in the home population at all, which are functional. Not only that, since these variations or bends in the cascades themselves can occur at any point, the effects that I'm talking about have no stake whatsoever in when they occur in the cascade. Some of them may occur quite early in the cascade and by definition produce a strikingly different creature. This allows for all manner of degrees of change to be associated with the division of subpopulations alone.